here in this room are at different stages in CAD. Some of you have worked on CAD, some of you don't even know what CAD is. But I hope to just kind of give you guys a general overview of why we, as a team, 971, use this CAD. So CAD is an acronym for Computer-Aided Design. Now, it is basically the use of computers to create a design. And it's our link between the ideas that we create, our prototypes, and our robots. So it allows us to kind of just bridge all these ideas and create one cohesive idea. We use SolidWorks as our CAD program. It is our software that we use. It runs on Windows. Sorry for you guys who use Linux, but it is exclusively on Windows. It works really well. A lot of engineers and designers use this throughout the world for many different applications, and it is kind of a great thing to know in general for all areas of expertise. Yeah, excellent. So why we use SolidWorks? Plain and simple, it works. I mean, it's the best software that we've worked with. I mean, you can see some teams use Minecraft, apparently. No, but it works really well. It has accuracy, efficiency. It allows us to build what we can, and our sponsors actually understand our ideas. So that's a really important part. And it's free. So SolidWorks sponsors us. Normally, engineers would have to pay a fair amount to get this software, and we just get it for free. We have to use it.
I think it's 6,000 a copy.
6,000 a copy. So just to put it into perspective, we're lucky that we get to use this. So our process for using SolidWorks throughout the build season, we start with prototyping, and we find our best solution. So we CAD up, let's say this year we have a Frisbee shooter, and we want to see which one works better, a linear shooter or the J shooter that we are using. And so we CAD up both of those. I'm not sure if we did that for this one, but that would be an example. We would CAD up both shooters and then see which one works best. After that, we take those prototypes and see which one works best and put it into our design. And we implement those prototypes, which is pretty cool, and see which ones work, which ones don't, and create a functional robot based on that. And then lastly, we have drawings. And this is basically getting 3D models and putting them onto a 2D sheet of paper so that the machinist can understand what the design is and how to manufacture it. So you guys, all of you now, have worked with drawings to create parts. Your part training, that little sheet of paper, you can see the bending, the tolerances, exactly what goes into making that part. And so you can make it based on that. So we draw we'll show you actually, this is the drawing of the third our robot now that's used for competitions. It's very complex. We create everything on CAD, which is really great. Not a lot of teams, I don't know, very few teams do this. And it allows us to, have FEA, which is finite element analysis, and kind of see what works, what doesn't, even after we prototype. And it's pretty cool.
You have to go back to your slides.
Yeah, slides. Okay, so getting parts made. Essentially, we take those drawings and our sponsors take those, what we send them, and make those parts. It's pretty cool. You can see here is the drive base for last year's robot, which was basketball. See all the different parts. Pretty cool. So now, SolidWorks in a nutshell. Many of you may have worked with it and know what this is, but essentially, first we start with a sketch, which is the 2D basic parameters of the robot, of the part. Then that comes into and makes a feature. And the feature is kind of this extruding or cutting of and making a 3D version of just that plane. And a part is various features made from extruding, cutting, all of these to make kind of a part. I mean, I'm sure you guys are familiar with what a part is. And parts go in and we make them specifically seeing what works to make an assembly, and then various assemblies go into making a robot. So yeah, I hope you guys are now wanting to learn a little bit more about CAD or continue your CAD training. I think it's really good to learn about the big picture of CAD and getting that and bridging like your learning and basically our product. And so if you guys want to learn more, you can have an online download. I'm not sure if that's current. I don't know if we use
Well, I do
online.
have SolidWorks
Yeah.
student license that people can download for their computers.
Ah,
You
right.
get 50 licenses, so people can put them on their home computers so that they can work on it.
Great. And yeah, and we also have you could borrow a CD from us. We're looking for that. And you can also look over old designs. This is really great if you get access to SBN, which is our repository for all of our previous robot CAD designs, our current, our third robot design, and you can see exactly the parts, the sketches, the features of those past designs and get inspiration and various other things from that. It's pretty cool. Yeah. Questions? Yeah.
Should I be working on?
Yeah.
How do I get access to SVN?
So you can talk to Michael, I think is the best answer for that, Mr. Shu. And anything to comment about that?
So the way it works is I have a web form you go to and you give me a username you want to use, name and all that stuff, and a password. Password I'm going to see, so don't give me one to your bank account. And then I create an account for you. We have several pages on our website that talk about how to use Subversion. Need to read those. It's James is going to show us that, right? How do we find anything if we're not sure on the website? We search, just like Google.
We're a big fan of searching things on the website.
SVN usage, there you go, top one.
Yeah, so you can read this page, understand why we use it, and the rules for SVN.
Back towards the top there, in that third paragraph, is step by step on how to install it. So, between those two pages and the links they link to, learn everything you want. Brian actually read the whole user guide for the thing, and I now go to him for advice. So if anyone else wants to do that, be really appreciated, because Brian's going to graduate, and we need like 10 people to replace Brian.
It's complex at first, but once you know your way around SolidWorks, you really understand all these different parts.